Hello guys, today we're going to talk about microcontrollers. In particular, we're going to talk about the Arduino. So you have probably been hearing a lot about Arduino and all the brilliant ways it could be programmed using C language to receive input from other devices like buttons, sensors and knobs or displays, and control outputs through physical components like lights, speakers, servos and motors. So let's talk about what is an Arduino really. Since 2005, the advent of open source electronics, especially the Arduino, had a profound effect on low-cost, easy and flexible programmable microcontroller platform. That means an Arduino is a type of microcontroller, and a microcontroller can be thought of as a very scaled-down computer, which contains components such as a processor, small memory for storing simple programs, and various input-output pins that produce an electrical current as a result of instruction in our program. And also, microcontrollers are mostly designed for embedded applications, and they are heavily used in automatically controlled electronic devices such as cell phones, cameras, washing machines, and etc. Okay, then let's talk about Arduino boards. So, this is an Arduino Uno. In this video, I'll be going over just some of the main components of this board. This board, it has a microcontroller which acts as the brain. The other components embedded in the board supports the proper function of this microcontroller. This is the power jack of the board. This is where the electricity comes to the board. Board itself operates at 5 volts. But it can get a voltage of 7 volts to 12 volts from this. And this port connects the USB cable to the computer. This part of the board is the power supply pins. This is where the electricity gets in and out, and it has a 5 volts and 3.3 volts output pins, which can be used as a supply electricity. And also there are 2 ground pins. The V-in pin is another way for the electricity to get into the board. These are the analog pins. They are specialized pins designed to input analog signals coming from analog sensors. In this board, it has 6 analog pins. These pins also can be programmed to act as an digital output pins, but by default, they are used as an analog inputs. And these are SCL and SDA pins. These pins are used for interfacing complex devices. Okay, you can see this pin which is named as AREF. This is the analog reference pin, which shapes the desired reference voltage for analog input calibrations. It can change the reference voltage and the analog inputs, which by default is 5 volts reference. Here are the digital input and output pins. These pins can be programmed as an inputs or outputs. That means it can read or give a voltage of 5 volts or 0 volts. Pin 0 and pin 1 are connected directly to the RX and TX of the microcontroller. If you want to communicate with the microcontroller directly, you can use these pins. You can notice these streaky lines before a certain pin number. These pins can act or pretend to output an analog signals. If you want to control the speed of a motor, you can use these pins to do that. And also there are 4 built-in LEDs. This LED is connected to the 13th digital pin. These RX and TX LEDs are indicators. When the RX and TX LEDs are blinking, they indicate that there is a two-way communication between your computer.